Now what we're going to look at is how to use fprintf functions and stuff like that. So if you've ever programmed in C, fprintf is something that you use all the time. If you're in C++, you're probably using cout. But fprintf is a great way to be very, very, very controlling. So if you're a super, super controlling person, then fprintf is like the most amazing thing because you can pretty much control absolutely everything about it. So there's a bunch of fprintf formatting things to learn. There's fixed point, exponential, decimals, general, character string. There's also this /n thing. So it comes down to this. Say I wanted to say fprintf, you are a snuggly wumpkins. And so if I do that, and I run it, it's like you are a snuggly wumpkins. But then look what it actually does. It actually ends my prompt right here. So I would say x equals 5. So if I wanted to fprintf, you are a snuggly wumpkins, and then I wanted to do it again, I'd say like, no, for realsies. No, that's not how you spell realsies. No, for realsies, you are. Come here. So I say, you're a snuggly wumpkins. No, for realsies, you are. If I go like this, and I play it, then look what happens. This goes here, and then this goes here. And then the little prompty thingy happens right there. So there's actually this little thing that we do. I think it goes on the inside. Yes, it goes on the inside. This little thing right here, \n, is a new line character. So \n means new line. So I can actually put in like 2 enters. Like I could forcibly double space it. I could put like just 4 there for no reason, and there I've got like my little /n thingies and no snuggly wumpkins, like that. And it makes me happy. Okay, so there's that. That's kind of like the basic printf thing that you absolutely have to know in order to move on. So that means new line. Then we start off, which one do we want to do first? Let's do that fixed point. So if I say, let's do something new. CLC, yeah, we'll say x equals like 5 or something. So I'll be like, okay, x is 3, and then I want to say, wait, that's not 3. I don't remember whatever I said. We'll make it totally different now. X is 13. So if I wanted fprintf, I could say, I ate, well, how I would used to do it is I would do like a num to string, and I'd say, I ate num to string Hot Pockets. But if I want to say, I ate 13 Hot Pockets, I could say, I ate %f Hot Pockets. And then what I do is I put in a comma, and I'm like, x, that's what I want you to put there. So basically this %f thingy is kind of like a placeholder where your number is going to go, and then the number you're going to put there is x. So I ate f Hot Pockets. Okay, but I didn't put the new line, so it looks stupid. So I'm going to go ahead and put the new line in there. I ate 13.0000 Hot Pockets. I'm very, very, very certain about the precision of the number of Hot Pockets that I ate because I can count. Okay, so that kind of looks stupid. So let's do basically the same thing. Let's see, what else can we use? We can use E. We can use E. I ate 1.3 times 10 to the first Hot Pockets, I guess. There is G, I think. G and D and C. All right, I can say I ate D. D is a decimal. And then G is, I think G is like general and, oops, space, Hot Pockets. What I think that G does is, and I'll look it up, yeah, it kind of does the best guess. I'm going to call this Matlab's best guess. So %G is Matlab's best guess. F is fixed point, so like a certain number of decimal places. E is obviously exponential. D is decimal. Well, I don't know why they call it decimal because it doesn't show decimal. I'm going to call it decimal. I wonder if there's a better explanation. Oh, yeah. It doesn't include trailing zeros. I'm going to say ish. Decimal-ish. Most of the time you're going to use F or G. So anyway, so if I want to eat that many Hot Pockets, I can. So yay, we can eat Hot Pockets all day long. Okay. So to give you a little bit more idea how this works, so say I wanted to say x is 12 and y is 18. Then I could say if I ate like Hot Pockets and what else do you have for breakfast? fprintf, I ate, I'm going to use G because I don't want it to show the decimals, and that's going to usually be a good job of catching what I want. I ate that many Hot Pockets and that many, I almost said rotary saws, but that's not right. You don't eat rotary saws. What else do you eat besides Hot Pockets? Um, 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 why is this the hardest thing that I've had to do all day? Uh, not a couch potato. That's also not something you eat. What do you eat? I had a sandwich. Okay, this is really hard. I have to remember to do the new line, close it off, and then hit a comma. Now whenever I put in X and Y, it's going to put that then in the order that, that I listed it. So if I put X and Y, then I'll do X and then Y. If I said Y and Y, it would list Y twice, 18 and 18. So they don't have to be in alphabetical order by any means. It's just whatever you order, you put them in the order that they're going to show up in. So that's actually pretty cool. And you're like, okay, well maybe I can see the appeal of this, but this really isn't that fantastic. Well, wait till you see what we have in store. Okay, so let's say that I didn't have anything nice and pretty like decimal, like pure integers. So like say I had 6.5 and then this one was 1/3. So this is going to cause all kinds of problems. So so if I say %G Hot Pockets again and %G sandwiches again, X and Y, you can see how that's going to look. So I eat 6.5 Hot Pockets and that many sandwiches. That's very, very precise sandwich. I eat 1/3 of a sandwich. Okay, so that's kind of goofy looking. So I can fprintf I8. Now, I can actually control the precision by saying point to F. And that's going to give me 2 decimal places with a fixed point thingy. Hot Pockets and %2F sandwiches. Like that. So see, now I've got a 2-point decimal precision here and a 2-point decimal precision here. So that's kind of neat. Let's see. What else can I do? I'm going to erase the sky. I can actually control how do I say this? How much space this takes. So say for example, I had that many Hot Pockets and that many sandwiches, and then I had more Hot Pockets and sandwiches. And because I'm doing like a thumb drive, not a thumb drive, an eating drive of food. Talking is really hard today. I ate, okay, so I'm gonna do this again. I can't spell sandwiches. That's funny. Okay. So there's X and Y, and then I'm going to go A and B. Okay, so now I print this out, and I'm like, well, this looks kind of stupid, because see how this is, like, kind of scooted over, and I kind of wish that, like, they took up the same amount of space. So one of the things I can do is I can say, okay, well, this guy took up 1, 2, 3, 4, 5, 6 spaces. Okay, let me do that again. 1, 2, 3, 4, 5, 6 spaces. So what I can actually say is I can force the other guy to take up 6 spaces as well. See, and now he takes up 6 spaces. This guy takes up 1, 2, 3, 4, 5 spaces. So I can force the guy above him to take up 5 spaces as well. And then everything lines up and it kind of looks pretty. So this is why I say if you're a total control freak that fprintf statements are amazing, because they do allow you to have that crazy awesome level of control and fidelity, or whatever else you might want to call it, where you can really, really force things to line up in a nice way. Now, one of the things that's a little weird about the fprintf statements is they don't exactly work precisely the way you think they're going to, the way Matlab normally does stuff. So let's make a table of stuff. I'm going to go 1 through 10, and then I'm going to make a table that shows like x squared. Okay, and then I make a table that's x and blah, like that. Okay, so I've got this little table. In fact, I don't even need to do 1 through 5 because that's too many to look at. Okay, so there we go. So there's my little table. Now, if I want to use fprintf to print this table, this is, okay, so just check this out because this is kind of crazy. Kind of super awesome crazy. Okay, so I go fprint, but I can't spell fprintf. Come on, girl. fprintf. Blah. I'll just do this. Or I could say that squared is that. And you're like, okay, well, I'm kind of making progress. I'll make it g's, because g's are general. They're not really general, but that's okay. So then I'll say, I want you to do table. I think that's how you can do it. So you're like, wait a second. This isn't right. This isn't right at all. You're like, this makes absolutely no sense. Okay, this is too much fun. Okay, so we have 1 squared is 2, and 3 squared is 4, and 5 squared is 1, and 4 squared is 9, and 16 squared is 25. You're like, no, that makes me so sad. Okay, so then you really have to look at what's going on. So I'm going to display that table really nice and pretty the way we used to do it, like that, so that you can kind of see what's going on. So this is table, the way it's supposed to look. 1 squared is 1, 2 squared is 4, 3 squared is 9, okay? But right now what it says is 1 squared is 2, and then 3 squared is 4. So hopefully you're seeing that Matlab, because it thinks in columns, is going down the stupid column first. So it's going 1, 2, 3, 4, 5, and then this guy right here. So it's saying 1 squared is 2, 3 squared is 4, 5 squared is 1, 4 squared is 9, and 16 squared is 25. Okay, so that means that if you really, really want to do something like this, that you have to actually invert the table to where your rows that you're trying to display are actually your columns. And see, then that's going to fix the problem, because if I display the, what you call it table, the transposed table, so now I have 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. So the way that you get around this weird table thing is to actually transpose the table. So this is important because this is actually a really, really good way to do this kind of stuff is with fprintf statements, because say you had like, you know, some degrees, or, you know, say between 0 and 90, and you had 10 of them, or 5 of them. And then you want to do signs, or sine of degrees, and then you want to do cosines, and that's cosine, degree, and then we're going to do tangent, because why not? Okay, and then you make like a little table, and it's degree, can't spell degree, sines, cosines, and tangents. Okay, and then I display the table. Alright, so I've got this, and this is lovely, and this is fine. But what you could go and do with the printf statement is you could actually go in and control like how much fidelity do you really want to see in these numbers. I changed that. Oh, it's fine. So I could come through and I could actually create like a really well-spaced little thing. So I could say fprint, can't spell that for some reason, fprintf. So I could just start off by saying, okay, well there's %f, and I could even go, I think I could do that. Let me try that for a second and see what happens. Okay, no, well, it doesn't work. Okay. So I could actually say %f, new line, because there's 4 of them. And then they all kind of smush together. I think I can do this. I'm going to play. Doo-doo. Yay! And then doo-doo. And then doo-doo. And you're like, what is this craziness? Okay, so this craziness is the tab, and that's kind of neat. I don't know, I just think it's kind of cool because it looks like complete garbage, and right now it is complete garbage because I didn't do that, but it's still kind of garbagey. But it's just kind of crazy that it tabs it over and it looks weird, and it's kind of fun. So now I could say, well, I don't want to show all that extra stuff, so I don't want to show all those decimal places. I want to show a total of, say, 5 characters with 2 decimal places. So the decimal point takes up one of those characters, so you're going to show 2 decimal points, or 2 like fractional numbers, so like a tenths and a hundredth. I'm going to show the tenths place and the hundredths place, a decimal, and then 2 numbers in front of that, potentially, if they are there. So that's what I need. So the hundredths place, the tenths place, the decimal point, and the next 2 numbers if they happen to be there. So then I could do that over here too, 5.2, and then 5.2, come on, and then 5.2, okay? And you could even say, well, for the first one, I really only showed 1 decimal place because all the other ones are zeros, and then it lines it actually up on the decimal. And that's something that you don't necessarily get here. The 0 is way over here, and here the 0 is nice and lined up with the other things that are going on in your column. So it's actually kind of neat. I can put tables, and I don't know if this is going to work. I think I can say degree, sine, cosine, tangent. There we go. And then if I don't like the way the tabs look, I can always go add an extra space here or there and do that. In fact, I don't even have to put the tabs in there if you don't want to. You can just physically space them out. That's not a problem either. It just takes, the tab kind of gets you close to the right place, I guess. So something like that. So fprintf really does give you a lot of control. You know, since tangent gets pretty high pretty quickly, you know, if I was going to, like, if instead of going from 0 to 90, maybe I was going from 80 to 90. Well, those numbers don't get that big that fast. Say I was going from 89 to 90. See how these numbers are getting fast and they're starting to get pushed over? So I could actually change it to where instead of showing it as a fixed point, I could show it exponential. So remember, E is for exponential. And then it would show all of those, you know, kind of like that if I wanted to, if I was really getting up that high. So, I mean, it's just something else to think about, is they don't all have to be done the exact same way. You can play around with it and get different values. And even here on the sine, because it's gotten so small, I can't really see, I can't see the difference there either. Whoa, like that. So there's just all kinds of things you can do with fprintf. You have a lot of control over how you want to show things. You can show things with different decimal places, different widths, different sizes. The biggest thing that a lot of times will get people when they're displaying tables is not to remember that little apostrophe, that transpose signal at the end of table, so that since Matlab does read in columns, that you don't actually want it to display by column, you want it to display by row. Now you might even wonder, well, why do we even put things in a table to begin with if we're just going to have to mess with it later? So why couldn't, instead of just doing this, why couldn't I just say put in degrees, and then sines, and then cosines, and then tangents, and then just have it read it through like that? The answer is actually kind of straightforward and simple. So Matlab, again, because it's thinking in columns, it's not actually going to do the first one from here, the first one from here, the first one from here, and then the first one from here. It's actually going to run through all of the degrees at first, then through all the sines, then through all the cosines, and then through all the tangents. So I'm going to go back to my normal pretty words. But now you can see what it's doing with degrees. The degrees were 0, 22, 45, 67, and 90. And then the sines were 0, 0.38, 0.71, 0.921. The cosine was 1, 0.92, 0.7, 0.38. So I'm pulling these numbers from here, but you can see that these columns are now being done like this. So it's really, really, really important to put the information into the tables, because if you don't put them into the tables first, then when you actually try to run them with Matlab, they definitely won't work. Also, a little quick note about this \n's is to make sure you understand that you can use this to make really obnoxious code. Because if you think that this is obnoxious, I mean, that looks pretty stupid. If you ask me, fprintf. So I can actually say, I like to put things on a lot of different lines, and there's nothing you can do to stop me. Okay. Now I know that's kind of hard to see, so I will put a little ... so you can. Oh, really? You're not going to like my ... You don't like ... in fprintf, you little snug. All right. Well, there you go. Well, I like to put things on a lot of different lines, so there's nothing you can do to stop me. So know how this is going. So I like to put things, and it almost looks like I'm saying /non, but I'm not. I'm saying /on. Instead of saying /nan, I'm saying /n, and instead of /no, it's /n, do, stop me. And I can put that there. And in fact, if I put the new line here before the period, you would see the new line would go, there's a period, and then it's going again. So it does like exactly what you want it to, what you tell it to do, which is a little weird. Another special character is, say I wanted to say, you know, if I had a percentage and x was 13. For some reason x is 13 a lot today. I like this class. X%. Well, I can't say x% of the time. So say g% of the time. and then I put in an X, and I run it, and it says I like this class 13, and it doesn't do anything. So you're like, but this is a percentage. How do I show a percent sign? Well, kind of the same way you do the apostrophe sign. Instead of doing apostrophe, apostrophe, you do percent, percent. Now I've got that stupid space in there, so I actually have to back it up. So I like this class 13%. We're going to make this a 9, because that's better that way, 93% of the time. Like, if you're going to slash in, and everything's all good and happy with the world.